Learning a new web framework takes a lot of effort. Reading just one book on React is 307 pages. Doesn't it sound appealing to just remove these bloated frameworks? So, is it then worth the effort of learning about this new web framework, FastHTML? Or will it soon be also forgotten like so many others before it? Before I give my opinion about FastHTML, let's go through the what, the why, the architecture, compatibility, customization, ideal use cases, communities, and resources available for FastHTML. All that goodies that gives a hint about the future for this framework. So let's start with what is FastHTML? It is in fact a new Python library that creates a web server, HTML and HTX support. With that, you can build modern reactive web applications. So what is the original purpose of FastHTML? It wants to replace the big and bulky web frameworks like Angular and React with a lightweight one. Write less code and get more done. Move all transport into an HTML language. Moving on to some key features. How will app performance be affected by FastHTML? It moves the computation updates of HTML and HTMX from the client to the server. On the server, where there is often more power available. The actual rendering of this HTML will be the same in both cases, done by the client. I've been looking around for some performance evaluations and really seen nothing much published as of yet. If you've seen anyone, please comment in the comments. I would love to see some. So, what about ease of use when it comes to FastHTML? First of all, it's easily installed with the pip command, as so many other Python libraries. All code you write is written in Python. App code is supposed to stay small and easy to get an overview of. But let's keep a minus in our heads here. The coder actually needs to understand both HTML and HTMX details to reap all the benefits of this framework. Then, what core technologies are FastHTML built on? It is based on the Python libraries UVcorn, Starlet, and HTMX. In case you would like to dig deeper into those. And what about compatibility? Well, FastHTML, as it is a Python library, will run on anything that supports Python. The HTMX parts works with any browser that supports JavaScript and XML HTTP requests. And that is about all of them, even some of the Internet Explorer ones. You can also use HTMX alongside other JavaScript libraries if you want. That increases compatibility. Now, what about the actual architecture for using FastHTML? The library FastHTML contains predefined HTML functions or components, if you will, defined in Python. That speeds up coding of your web pages tremendously. The HTMX parts is added by defining certain arguments to the components if you want them. But if you're just using HTML, you don't need to define them at all. Now, shifting HTML generation from the client to the server should speed up execution compared to React applications. But we're still waiting for performance evaluations on this part. Now, how flexible is FastHTML? Can you customize your application? Yeah, you can extend the predefined set of components with your own custom components. This could come in handy if you, for instance, are using your own HTML tags. Another way to expand is to extend with another JavaScript library, if you wish. So, what are some stated benefits of using FastHTML compared to traditional frameworks? For the first, reduced need to transfer bulky web framework code over to the client, also executing it there. So we have both load times and execution time in the client. Second, all communication is HTML or HTMX. No need for JSON transcoding of data. On introduction of new coders, there's no need to study a bulky 300 pages book from O'Reilly about React, for instance. And for the last, all code can be in Python. That is a good thing, at least according to me. Then, what about developer productivity if you're using FastHTML? Now all can be put into one file. That is very efficient for a small team, but maybe it could be a hard thing for larger teams. All in one file means also it will break the MVC or Model View Controller model that many are using. Or can it be maintained as well? We need to look into this later on. And what are some ideal use cases for FastHTML? Typical use cases is not really clear yet, but we can think about some of them. Definitely, we're talking about early prototypes, MVPs, testing servers, and such small applications. I also heard about the ability to handle streaming data, and that enables dashboards as well. So let's keep an eye on who jumps on this FastHTML ship and starts using it officially. Then what about communities around FastHTML? Well, the GitHub that develops FastHTML has got 48 contributors. There is also a Discord for developers and users. Link in description to both of them. And what resources are available for users of FastHTML? Of course, you can get the code directly from GitHub. And there is also a gallery of ready-made components that you can just download. Link to those in description. And the future. What is known about the roadmap for developing FastHTML platform? It is an open source project, but it doesn't have any published time plans at all. Some areas, like authentication and database integration, is still under work, so it's open to suggestions and some help in these areas. So to start summing up the pros and cons. First, the pros. It is a new approach to single-page application. I kind of like it. Probably faster load times than the behemoths. It's an easy to start, small projects in it. Let's try that out. It is Python everything. What's not to like? It's supposed to give compact code. Perfect for small teams. Let's look into that one as well. And then the cons I can see right now. It is open source only, so there is no company backing it up at the moment at least. We'll see what happens on that one. There is not a full coverage of what a web framework needs yet. Auth and databases are under work. That can be fixed. It is also, I'm sorry to say, breaking the MVC that many have organizations around. So the question is how to make larger teams divide the tasks between them and how to get that into the code. Can be fixed, I guess. Let's see. It also requires a deep HTML, HTMX knowledge by the coders. On the other side, we don't need to know the React or Angular framework knowledges, so it's just another thing to learn. Hopefully, I'd say a smaller thing. Styling your FastHTML application is a bit obscure today. I'm not sure if it is a tutorial or if there is a missing tool. I'll be looking into that part later on. So finally, my conclusions. This framework can go anywhere. From dying in obscurity to becoming a major player in the web framework industry. I like the basics of it, and I will make some deeper tests myself later on. So even with all its current limiting factors, I'm excited about it. Are you? Let's go! In Python, from theory to practice. Let's start with a multi-page application controlled by HTMX. To give the basics of HTMX. Let's use FastHTML to do an HTML-only multi-page application in Python. I already have an MPA done in Django. Let's just replicate that one using FastHTML and look at the differences. How much code do we need to write for this one? The same old high-level question still stands. Is it worth the effort of learning this new framework? So let's build this MPA in 4 steps. First, pages and routing. Second, content and forms. 3, email validation. And finally, database integration. Finally, let's compare the code and look at some surprising results. And then, what is the next step in evaluating the FastHTML framework? Now, what does this Django app do, I hear you ask? It is a simple app that collects emails in exchange for a PDF, or let's call it a lead magnet. It is implemented in Django and Python, and it's using the MongoDB in the back end. So it's a perfect example that we can make a copy of using FastHTML. Then what is needed to set up 5 new pages and do button routing between them? All pages of this application has got the same structure. It's using 3 cards. One on top, basically carrying the title of that page. Then there is a second card containing the contents. It could be text, images, or form. And on the bottom there is a card containing buttons just for navigation in the application. Now to show a page, FastHTML sets up a route with this decorator @RT and a link. Since this is the /root, it signifies the root entry of the application URL. This is followed by a function defining the HTML action. In this case, a get action. Def get. The get function defines the 3 cards that we're talking about as components, and then some text should be in there. We also have a button in the content card. This button should switch us over to the sign-up page when we press it. This combination of components, form and button, will be used all over this application. Then we can just repeat these basic steps for all the other pages. The sign-up page, the thank you page, and the 2 link failed pages that we will use later on in email verification. Now that we can run around these empty pages, we can celebrate one victory and move on to the next challenge. How about celebrating that with a subscription to this channel? In that case, you will learn a lot about FastHTML. The next challenge is content and forms. How is that done? The content in this case is just a copy of the text available in the Django application. So we just copy that text and dump it into the appropriate components on the cards. The form, where we enter the email and our names, is a bit more interesting. The form function takes a lot of parameters. The 2 first defines where the data of this form should be sent. So the routing and what action that should be used, in this case, a post. Then there is a second parenthesis, and that one contains a list of the inputs that makes up this form. First, we have an input of type email with name, ID, and placeholder. We also set a required setting on this one, because in this application we really want the email. Second on the list, there is a text field where we can enter a name. Third, there is a field set which contains a label with some headings together with a checkbox that we can check. You know, the good old GDPR. And finally, we have the submit button. Now, there seems to be a requirement to define the type of the struct that a form reports back to its post function. Here we use the decorator @DataClass, followed by the class type definition, but in this case I call it signup with a big S. Then it is time to start the actual post function of the signups. @RT signup and def post with the parameter data of type signup. In this case, just let us print this struct to the console and assume that everything is as it should be. And when we're done with that, we redirect the user to the thank you page. And for that, we're using the redirect response component with the address of thanks and the status code of 303. So, when we can fill in an email and a name and press submit, we can celebrate another victory and move on to the next challenge. When this app gets a new email, it must be verified. I choose to do this by creating a dynamic, personal and time-limited page in this application and send a link to it to the email that has been entered. As long as it's not a fake email, the user of it could access the freebie, in this case, a PDF. The link in this case is a combination of the timestamp when it was created together with the email that has been entered. But you can use any kind of information in this link, I guess. Now I have this function implemented in the function processNewProspect, which I copied from the Django implementation, also in Python. However, I needed to adapt some imports since the implementation in Django uses Django imports. So I had to change them back to some standard Python library functions for email and time handling. When it comes to the email, I'm doing a multi-part email containing both a text version, an HTML version containing an image of a QR code. QR code that leads back to this personal time-limited link. As of now, I don't send those emails, I just print them out into the log to see that they work as they should. And they do. So, when we have a printed version of the email that looks okay, we can celebrate yet another victory and move on to the final challenge. Our final challenge here is an integration to MongoDB. FastHTML as a framework does an SQLite integration out of the box. Here I will just ignore that one and do a Mongo integration out of the box using the PyMongo library. When do we need this database accesses? The write is needed when an email has been sent off to the user, because we want to store that link in long-term memory. We find this write in the signup form, the signup post function. db mlist prosp insert1 and ent. Now for the database entries, I have defined the database type entity, which is a slight increasement of the post data. We need some status and some timestamps to pull off this function later on. The read is needed when someone tries to access the application with their personal limited links. Is the link found in the database? If it is found and it's not yet expired, we update the database with the time of this PDF retrieval and mark the email as valid. This thing is done in the function of our last page, the dynamic page. It is @rt/mung/link in curly brackets, followed by define get with the link of type string. This is the actual link verification function. It checks the time now and does a search for the link in the database using find one. If it is not found, we raise an exception and redirects the user to the link not valid page. So if the link is found, we check if it has expired. If it is, we redirect to link expired page. If it is valid, we update the database with the time of collection and validation, and then responds back with the PDF file, the lead magnet itself. So, when we're able to catch bad links, expired links, and retrieve the PDFs, we are done with this implementation. But before we celebrate too hard, we can now really look into what we have got. Apart from just reading the code, how can we really compare these two implementations? We can look at it in the statistics side as well. If we look at the number of lines, Django needs 276 lines of code, while FastHTML needs only 185. That is, Django needs 50% more lines. If we do a word count, Django needs 1026 and Fast needs 917, so about a draw in words. I should say that this is a word processor counting words here. It's not really optimized for Python. But what about characters? The Django app uses 6,400, while Fast is using 5,300. It's about a 20% increase for Django. And finally, files. Django has got everything covered in 10 different files in a number of directories, while on the Fast side, there is one file with everything in it. Now, these numbers, they surprised me a bit. I was actually expecting Django to be more compact. I expected Django to provide more from the framework itself, but I seem to be misguided in this belief. So, less code for the FastHTML implementation. Yay! About the files. You can actually choose to split the FastHTML file into separate files. And you can do that because you want a better structure. But if you do that, you will need more imports and some other functions. This will lead to more rows and more characters. For an example, splitting the FastHTML application into 10 files will decrease the line percentage from 50 to somewhere between 20 and 30%. And that is from imports alone. We need to keep this effect in mind when we look at code structure in a future video. All in all, round 1 goes to FastHTML. Now, with the HTMX basics under your belt, let's dive in to a single-page application. HTML can transform a multi-page application into a single-page application. How do we utilize HTMX? To do that using FastHTML, let's transform my application lead magnet from a multi-page application to a single-page application. And what do you say? Doing less as a single-page application. Will we see any performance gains? What does my sample application do? It is a lead magnet application. It gives out a PDF in exchange for email and name information. If we make a drawing of how it looks today as a multi-page application, these are the different pages that we are jumping around in. Now, it's only the sign-up part, so the 3 pages in a circle, that we will translate into a single-page application. The actual delivery of the PDF can be seen as a single-page application as it is today, so we will just leave that one out for now. So these are the 3 pages that we will transform. It's the welcome page, the form page, and the thank you page. And here we have my want. I want to keep the top with the title, and I want to keep the bottom part as a navigation. I just want to switch out the content of the middle card or the actual content. So that is my vision for a single page application. So how do we design this card flipping as a single page application using HTMX? There are actually 4 actions in HTMX that we need to look at. The first one is delete, and that is typically used to delete a button after it's been pressed or delete some text after something else happened. The second one is append, and that is, for instance, to put a new line in the end of a bullet list. And then we have prepend, and that is, for instance, to put a line on the top of a bullet list. And for the fourth, swap. And swap exchanges some piece of HTML with another piece of HTML. So when we implement swapping our cards, we will be using the action swap. If you want to know more about FastHTML, then subscribe to this channel, because I have a few more videos coming up quite soon on this topic. So apart from the actions, what is more of importance here? The scope of each action. The default scope of one action, say delete, that is the HTML part that called for the action. So if you pull a delete on a button, it will just remove itself. That is the default scope, the caller HTML. Now we want to exchange the entire card. That is a much larger piece. And then we're using something that's called out of bounds. There are 3 ways to implement out of bounds, but I will only look at the easiest way, and that is to have an ID and then set the swap OOB equals to true. In our case, we will set an ID on the content card when we define it and just call it content. So transforming this code, we need to do 3 things. 1, put an ID on the content card, calling it ID equals content. And then we also define this card to have the HX swap OOB equals to true. This means we're allowed to swap out the entire content. Secondly, we need to define the action of the first button to be hx post to the root. And thirdly, we need to set up a function of post for root that actually returns the content of the card, which contains the actual forms for entering this information we need. In other words, returning the card of the sign-up form information. So let's take a quick peek on the code. First, we have the initial HTML code, which sets up the page from the welcome site. That one contains the button that points further to the post root. And then we have the post root function, which actually returns the function. Now, we have a third card as well. So this function, when we have filled in all the details and we press sign up, this sign up button will go to an hx function as well. So we need to change the form so it returns an hx post function itself. This one goes to the hx post dash sign up. This is not really a change of page. It is just internal routing. And for the last part for this one, we need to change the handler function for this form. As before, we wanted to set up and send the email, and we wanted to talk to the database. But in this case, we don't want it to swip to a new page. We wanted to return the thank you message to the card in question. And let's take a quick look at that information as well. If we're talking about handling the email in the database, look in this video where everything on that part is explained. There's no changes in those parts. So, after we have this, we actually have a single page application, the one that we wanted to have. Let's celebrate. Now, what do we need to remember from this one? Yeah, we have 4 actions: swap, delete, prepend, and append. And then we have the local scope or the out-of-bound scope. So, if everything is just hunky-dory, let's just run it. And while we do that, wouldn't it be interesting to look at the actual messages going back and forth to HTMX? I will look at this application using Firefox, and to see the messages, I'm using Tools for Web Developers. Here we have the first message. The TX message is just a empty get message, and it returns the HTML code. And this is what is shown in the RX message, the full HTML page of the welcome message. Now, the second message. This is when we press the button to go to the sign-up page. This is in the TX message of the second. It doesn't really contain anything. It's just a post to root, as we designed earlier. If we look in the RX part of this one, this is actually the HTML code of the card for the sign-up form, as we wanted. And then, if we have filled out the form and press sign up, we can see in the third message, first on the TX part, the form data that we have entered is transferred over to the server. And in the Rx part, we have the answer back from that function. And that is the information from the thank you page. I find it quite easy to understand what's happening and what's happening to the DOM model if you're using a tool like Tools for Web Developers or something similar. If you don't like Firefox, why don't you use Chrome? They have the same toolset. Now we have a running application. Wouldn't it be interesting to take a look at the statistics for the multi-page application compared to the single-page application? First of all, we have the code stats. If we look at them, we see that there are small reductions in code, but it's not really significant. Secondly, we look at the packets sent between the server and the client. Here we actually see a small increase, but it is small, not really significant, at least for this application. And finally, I'm looking at the runtime of the test suite. We're looking at 6.6 seconds compared to 6.3 seconds. It's a very minor reduction. So, all in all, minimal changes, I would like to say. Perhaps I need some better measurements to see any real difference here. But I'd say multi-page application or single-page application, in this case, it's just the same. So we're starting to get near a better answer on the question of what is actually fast in FastHTML. Running it is about the same speed as a multi-page application, which is about the same speed as a Django application. So actually the running speeds are compared for any kind of framework that you use, at least for this type of application. So the only thing that I can see is actually writing the code is fast, if you can keep the rules in your head. And that is the 4 actions and the scope of those actions. What is an app without styling? Let's dive in to how you can best personalize your creations. FastHTML is using the look and feel of Pico CSS as default. It is both perfectly fine and a bit generic and bland. How can we spice up the styling of our web application when we're using FastHTML? The simplest way to change the look and feel from the default is to just change one HTML element. This could be one button or a background color of one specific item, or maybe spacing of a text. So let's try to change the background color on just one of the cards of our example application. Do note that by default, all card background colors are more or less black. But here we have made the background color of this form card being gray. And this is how it's done in code. And as suspected, it is just an extra argument to the card function. We are setting the CSS background color to the color gray. So this is the first way to do styling changes, and we call this inline styling. The second way to change styling in FastHTML is this one. And this one affects all elements of one type in the entire application. And for this example, I choose to alter the font from a normal one to a monospace one. Now, we do this by setting a style element in the HTML header section. And if we're looking at the code, this is entered as a list of CSS arguments that's put into a style function and given to the HDR attribute of the FastApp call, as shown in this. And if we look at this one, we can see that all fonts in the entire application are now monospaced as we set in this setting. And we can compare it with the old one as well. So this second way of doing style changes is called class override styling. Then, for a third way, what if we want to leave Pico CSS behind? We can do that, but we need to do a bit more than. First, we need to tell Fast application that we don't want it to set up Pico CSS at all. And we do that by setting the argument Pico equals false. But then we also need to give it another CSS source. And we do this by inserting a link into the header section as before. Now, in this example, I have downloaded the Pico CSS file and then just altered it to my own liking. And what I've done is to change the background color of every card in the entire application. And I put this in a file from the local directory called mypico.css. And if we look at the results of this one, yes, every background color is now gray. And this way of handling style changes is called replacement styling. And now for the bonus tip. If you have bigger application, or perhaps you would like to provide your own CSS from a static file server or from a CDN network, you just need to replace the link that in the earlier example pointed to a local file sitting on the root directory. You can point that to any kind of file on the internet. Now, this works good for any kind of CSS file, if it comes from a CDN network, or if it comes from Tailwind, or if you have another CSS solution. Replacement styling can reach over the internet, wherever you choose to point it. And there we have it. We have 3 ways of styling our fast applications. We can do it inline, just changing one component. We can do a class override and changing one class of elements in an entire application. Or we can do a total replacement, and that can be done with a local file or something sourced from the internet. So now that you know about CSS styling, it's time to start creating. What creations you might do with that? Yes, you might also create a live dashboard. Can we build dashboards using FastHTML? Not that static, boring ones, but live dashboards that update constantly with real-time data and beautiful visualizations. And this with only some Python and my 6-step method. Let's look at what is needed, what can be done, how it is done, and how to take it even further. Dashboards has become more and more important over the years, as data, and especially visual data, guides most of us in our work life today. Let me show you how to set up a FastHTML-based dashboard server in 6 simple steps. So what is the simplest we can do of a dashboard? Yes, why don't we stream a digital clock to a client web page? Like this one. We have the hours, the minutes, and the seconds ticking away. What will the code look like for this one? In the server code for this one, we see 3 things. We see the page, we see the get function, and we see the generator. So, peg. So in the page, we set up the web page or the dashboard itself. In this case, we only have one thing that is streaming, and this is one paragraph. It contains some text that will later be exchanged for the time. Then we have the codename SSE swap together with the event. And this is server-side events and the label that we're using for this particular stream. Next up, we have an HX code SSE HXXT set to server-side events. And finally, we have the SSE connect, which point to a route that we're going to connect and get our streamed data from. And next, we have the get function. It's got a route called timesender, the same one that we used in the page. This one returns a streaming response with media type text event stream, and this is typical thing for server-side events. What it really returns as a message is this time generator. And that is the third thing that we're looking at, the time generator. This is a generator that it takes the current time now and formats it to hour, minute, and seconds. It puts it in a paragraph, and this paragraph should keep the time update event. Now this server-side event should also be the second parameter to the server-side event message is the event which we set to the label time update event. So this message is yielded, and then we wait for the next time to happen. And in this case, I just sleep for 1 second before the next time is generated and sent off with another event. Now, if you're not familiar with generators, they are just like iterators, but they never run out of content. They will be giving you a value for eternity, just like a randomized number generator, for instance. Now, the thing we have recognized in this part of the code is a pattern that we can reuse later on. And I call this the peg pattern. The page, the get, and the generator. There are a few options when we're choosing technology for streaming data from the server to the clients. And basically you can choose to use any of them. For the first one, we have web streams. They are double connected, so You can stream data in both ways. And they are practically used when we're doing chats or team collaboration tools. But they are a bit low level and you need to handle quite a lot of events like connecting, disconnecting, reconnecting and keeping a state of them. And for the second, we have client pull or polling. And using that technique, we get a lot of requests from all the customers into our server. At least if we're serving many clients. And for the third one, we have server-side events. Those are one-sided, sending data from the server to the clients, which is exactly what we're looking for with dashboards. They are also fully integrated into FastHTML via Starlet SSE. So in the end, I choose to go for SSE or server-side events in this rundown. Partly because it fits very well together with the dashboard application, and secondly, they're very good integration and very easy to use. So comment below with what technology you would use for your dashboards. Then, as a next step, what about streaming live data into a graph or chart? In the FastHTML gallery, there is an example using Altair charts. So let's go for that one in this example. And what should we show? Well, how about the CPU load of my local PC while I'm recording this one? Should be fun. Let's start at the imports. The first 4 were already used by the other example of the clock. They are used to setting up FastHTML and using server-side events. New here is the stuff from FH Altair, Pandas, and Altair itself. Next, we'll look at what scripts are included in the HTML header section. We set them up and make them a part of the initiation of FastHTML app. Here we have SSE links that is used to handle the server-side events. And we also have Altair links that is used to set up the charts of Altair. And then let's peg. The page has a new card with a div in it that's used for the chart. This one has an SSE swap set to graph update event, or the label that we are using for these server-side events. We set the hx to SSE just to indicate that we're using server-side events. And finally, we give a route to connect to where the data is coming from, the SSE connect, and we're using graph sender as this route. Jumping to the get function with the root graph sender. This one looks very much like the other one, except it's using the graph generator for the messages. And then we have the generator. I have my plot data as a list, but as a global variable with a list. And as I'm running Linux, I can use the top command to read how much CPU load I got at the moment. And inside the generator's eternal loop, we read this CPU load from the top command. Then we need to translate this one to a float value. And finally, imported last in the plot list of graph data. I keep my list limited to at most 10 values. You can do longer or shorter, whatever you choose. But I don't let my list grow infinitely. After that, I use pandas to define a data frame, where y is the plot data and x is just the range of the plot data. After that, it's time to set up our chart. We're using alter chart and give it our data frame. We set this mark to line as in line chart, and then we encode the x with x and y with y. And in the end, we set some properties on how big we want it. 400 times 200 pixels. Now we need to package this one for the SSE message. So we define an SSE message with a div, the old div from the page that we will replace, containing this chart, but rewritten by the function alter to FastHTML, so that everything is transported in the right way over to the client. We keep the SSE swap to graph update event and this SSE message, and we need to set a label on the message itself, and this is graph update event. Now that is what is yielded and sent off to the client. And then, in this case, I wait for 5 seconds before starting all over again, reading a message with top and generating the div that contains this new updated graph. Now, what will this look like in our windows? Since we update this every 5 seconds, it doesn't really fill up that fast, but after 10 times 5 seconds, we have a full 10-point graph. We can also choose to speed this up if we want to. And looking at it, my laptop is working a bit hard at the moment since I'm recording this and running this server as well. So it seems like it's standing just below 30% on average. Now, isn't this exciting to see that it's live? With this method, anything can come alive.
That was so disturbing.
Now, that was line charts. What about pie charts? Why not make a pie chart showing the disk usage on my laptop? Now, how would we peg that one? The page is almost an identical copy of the line chart. We're using one unique label for the disk update event, and we're using one unique route for the disk sender. And what about the get function? Yes, we have seen it before. It's look exactly the same, except it is using the disk generator. And finally, the disk generator. This one is using the dfh total command and sorts out the actual line that I want to use. From this one, which contains total, size, used and free, and also a %, I only look at the used and the free. These two values are put in a data frame. These two values is put into a data frame, which is put into a chart. And here we set the type of the to mark arc. In this one, we use the angle as values and color as disks. the disks are used and free. We do it of an equal size. The SSE message is put up in exactly the same way, using alter to FastHTML chart, and we use the disk update event label. We yield the result and sleep for about 30 seconds. And I take 30 seconds on this one because my disk doesn't really update that much over such time periods. Now, what will this look like? I need to start scrolling a bit. Yeah, it really looks like I have about 44% free on my disk. That's quite impressive, thinking about how long I have been using this computer. What if you don't like to have your charts or graphs standard white with black lines? Let's quickly try to change the background color for them, just to see how it's done. All that is needed is adding a configure option when we define the chart. Here I have set the background of the first one to, guess what color? Just to make this interesting, I also changed the color of the pie chart to another color. Guess what color that is? Now what will this look like? Yes, I set teal background color for the line chart and a pink one for the pie chart, just to be brand color to my channel. So check it out. Maybe not the best color matching, but all that is up to your imagination to change. We now have our graphs exactly as we want them. Now this was changing background color for the charts, but you can also tweak the most things on these graphs. How and if to do the legend, what the axis will look like. You can remove the mesh of the line graph, and you can color code the values in line graphs. And on, and on, and on. For any kind of tweak you want to do, see the alter documentation. I have a link in the description. Then we're in for the last, or maybe rather the first step that we need for the 6-step method, respeg. To be able to import a library, we need to have it inside our Python environment. These are often defined in a text file called requirements.txt, and they are often fed to the pip command or pip-e requirement.txt. So what's in my requirements file for these examples? There are only 3 things that I need to download to my Python environment, and that is FastHTML as is, the FastHTML alter thing, and pandas. The rest pip will handle for us. So this is the R in the respeg method, the requirements. Then we need to check the includes we need. And in this example, I'm using these 7 ones. But if you're not looking into datetime or not using alter, they all fall away. So these depends on what packages you are using. And this is the I in respeg. Then we have the script tags for the header section of the HTML. Basically, we're using it to include JavaScript libraries for things like the graph library and server-side applications and other stuff that you need. And this is the S in respeg for scripts. And then we have the page. And that one needs room for what we will fill this dashboard with. and how we sort them out and place them on the screen. Since we're streaming, we need references to SSE or server-side events. We need a label, and we need -XX sender, something to hook up the stream to. And this is P for page. And then we have the sender function that the client connects via. And this one looks very much the same for all. It just contains different generators. And the get is the E from Rispeg. And finally, we have the generator. A generator that forever gives new values, and they should be packaged in HTML content that we can replace using HTMX on the client side. And for that, we're using the SSE message and targeting the event label. There we have it, the 6-step method of Rispeg. How to make server-side dashboards using FastHTML. Now, I've been using altar charts here, and look at their gallery to see what kind of graphs you can use. They have simple charts, bar charts, line charts, area charts, circular plots, scanner plots, uncertainties and trends, distributions, tables, and maps, and some interactive charts as well. Even though I never tried them, there's also some more advanced calculations available. So look into the gallery, link below if you're interested in altar charts. But altar charts are not the only charts that you can choose to use. Here is a list of 10 other types of charts that you can try out to use. I haven't tried them, but give them a go. They might work better for you. Just imagine what you can do with these.
Mirror, mirror on the wall, who's the fastest of them all?
Let's compare Django with FastHTML. Who is the surprising winner?
FastHTML is a new web framework. Django is established. Which one gives better performance when implementing a simple HTML-based multi-page application? How do I compare these two frameworks without getting too much interference into the measurements? I want to look at data flows, CPU loads, and delay. Is FastHTML the fastest? We can crown the fastest Python-based web framework of them all. How do we compare two web applications? We can set up two application streams, from database to application, browser, Selenium browser controller, and a repeatable unit test suite. But if we're using different components in these streams, how do we know that the results belong to the applications themselves? So how do we eliminate the database dependency? We use one database. I use MongoDB for this one, and to that one I have two parallel tables or collections, if you may, one for Django and one for FastHTML. This way we get the same database delay for both applications. Want to go deeper into FastHTML with me? Then subscribe, so you won't miss the next deep dive into FastHTML that I'm about to do. So how do we eliminate the client part? We use the same test suites, the same Selenium WebDriver against the same client, Chrome. Now the only thing that differs between these two streams are now the applications themselves. Then, how do we measure data flows? I choose to use a tool called netstat from Linux. It can give a snapshot of an interface. In this case, we use localhost port 8000 and localhost port 5001. And for each of these, we take one snapshot before we run the test suite and one directly after. And then we just look at the difference between the two of them. Now, what are my expectations for this measurement? We are using simple HTML here. I expect these ones to be exactly the same. So on to the measurements. Here we have a table with FastHTML and Django. And the conclusion is the differences are very small. They are the same. Now, how do we measure CPU load? I use the Linux tool System Manager. That one can plot each core against time. In that plot, we can see any kind of peak load as well as the accumulated load under each curve for each processor or core. And we can see the general load as the volume under each curve in this drawing. This measurement should be good enough, I guess. What about my expectation for this one? Well, Django is a larger framework, so it should really draw a bit more CPU from this one. Then what about the measurements? Django has a peak of 58%, while FastHTML has got a peak of 65%. The area under the plots are roughly the same size. We can also look at the time it takes to run the actual test suites. For Django, this takes 6.6 seconds, and for FastHTML, it takes 6.6 seconds. So, my conclusion for this. With these tools, we see no significant difference between the two frameworks. They are the same. Now, how do we measure server delay? For the server delays, I use a Google tool called Firehouse. It provides a measure per page. My expectation for this one? FastHTML should be the fastest, right? So, looking into the reports, we see that Django is faster than FastHTML. Disappointed. So, my conclusion is that it seems we need to give this victory to Django, I'm afraid. So, is there a lesson here in this disappointment? Is there any way that we can speed up FastHTML to reach the same levels as Django? Actually, it is. Digging a bit deeper into the Firehouse reports on FastHTML, they give a tip that libraries should be served as static files directly from the server, instead of being fetched from the internet. If we do that, we can cut off about a second. And if we look at the difference, second is what we need. So doing this would actually put FastHTML on the exact same level as Django. This brings the delay measure to a tie. But here is an important lesson for using FastHTML. If you want speed, you should serve your libraries as static files. So, my final conclusions. For simple HTML-like web applications, Django and FastHTML have about the same performance. There is no fastest to be crowned. Simply choose the one you like and the one you know. No real shocker there. If I ever release another FastHTML video, it will show up in the playlist over there. Just click it and I'll see you there in just a second.